Alright, so let's proceed to the part 2 of our video on roots of unity. Okay, so this is part 2 of our roots of unity. And the question was, for all values of x, s sub n of x is defined by the sig s sub n of x is equal to the sigma of x to the n over n factorial from n equals 0 to 3n. Show that s sub n of x plus s sub n of omega x plus s sub n of omega squared x is equal to this. Now, before I go on into this one, maybe some of you have no background yet of what is the summation of series all about, okay? Or just for you to visualize what is this one. Now, so this is just an easy question, by the way. This is only 3 marks in further maths. So let's just get an intuitive idea of what is the meaning of this one. So if, for example, you have the x to the n of n factorial from n equals 0 to capital N, okay, what does it mean is that the n begins with a 0, so that is now x to the 0 over 0 factorial plus x to the 1, so that is 1. So x to the 1, 1 factorial plus x squared, 2 factorial. So that is the meaning of that, and so forth and so on. Now, if you change this upper boundary and you make it n is equal to 0 to 2n, for example, all right. So what does it mean is that your n is a multiple of 2. Okay, so meaning of x to the n over n factorial, meaning this one will be equal to x to the 0 over 0 factorial, that is for the first one. And if n is equal to 1, so 2 times 1 is 2, so this is going to be x to the second power 2 factorial. If n is equal to 3, 2 times 3 is, if n is equal to 2, 2 times 2 is 4, so that's going to be x to the 4 factorial, okay? So that is the meaning of that. So therefore, this question here, for you to be able to visualize the meaning of that, it means that the sigma of n equals 0 to 3n of x to the n over n factorial is equal to, again, if n is 0, that's x to the 0, 0 factorial, plus if n is 1, that's 3 times 1, x cubed 3 factorial, okay, plus x to the 6 factorial, plus and so forth and so on, okay? So how does it work now in our question? In our question, it says that we need to show, that s sub n of x, the sum of this one is equal to this. Again, don't get shocked with the question. Don't get afraid of the question. All you just need to do is stay calm down. So you just calm down and just follow the definition as it is, okay? Don't panic. Alright, so let's try to look at this one now. So we want our s sub n of x. So we know that our s sub n of x, the definition is this. Okay, so let me just write it down. The definition, wait, it's not visible in the camera. So you have there the sigma of n is equal to 0 of 3n of x to the n over n factorial plus So this one is, that one is this one. Okay, that one is this part here. Alright, so that is that part. Now, what are we going to do now is this. S sub n of omega x. So S sub n of omega x, we have said, let's just follow this definition. Okay, so let's follow that definition here. Okay, there we go. So the definition says that S sub n of omega x is the sigma of omega x, because this is now omega x. So this is now omega x to the n, and that's all over n factorial from n is equal to 0 up to capital 3n. And the other one is that S sub n of omega squared. So we are now in this portion here. Okay, so let's try to do that. S sub n of omega squared x. So again, just follow the definition. That is now plus the sigma of omega squared x. So therefore we will change this with omega squared x. You have your omega squared x to the n, raised to the n, don't forget with the parenthesis, okay, divided by n factorial from n is equal to 0 to 3n. Alright, and there you go. That's it. And we would like to prove, the one that we're trying to prove is that this is equal to this. So we're trying to prove that this portion here is actually equal to this one. Now, for you to be able to visualize this properly, as you can see this one, because omega is a number. Okay, omega is a number. Therefore, even if you put this one outside, it doesn't matter because it's just gonna be the same thing. Alright? So therefore let's try to do that. So you have there, let's rewrite this. So sigma of n is equal to 0 to the 3n. Sorry if my handwriting is not that legible. Okay, let me just check the screen. Plus, you have there this one, I'll just put this outside, omega n. Omega n of sigma of n equals 0 to 3n. This is going to be x to the n factorial. Alright? And then you have there what? This is going to be equal to the plus the sigma of n to the 0, 3n of, sorry, I forgot to put the omega squared. I'll just put it here, okay? Omega squared or omega 2n. So this one, this omega 2n times this one here, times the sigma of x to the n over n factorial. Alright? I hope that you are not yet you're not yet dizzy with my solution here. Again, the thinking there is that omega is a constant. Okay, omega is a constant. So even if you put this to the left or outside of the sigma, okay, this sigma will not be affected. Alright? Because it's a constant. So omega to the 2n, then this is the sigma of this, then it will just be similar to that. Okay? Well, okay. If you cannot visualize, just imagine this one. Okay? So for example, you have there 2 plus, sorry, what am I going to do? 2 plus 2, sorry, 2 plus 4 plus 6 plus 8 plus 10, for example. What is this equal to? That is equal to 2 times 1 plus 2 plus 3 plus 4 plus 5 and so forth and so on. So meaning the sum of this taking the sum of this one times the 2, okay, is just the same thing as, taking the product of each one of this one. So basically it just follows the same logic as this one. Alright? Now, again, don't just relax there. And it's about to finish. It's about to finish. So what do we want to show? What I want to show is that this expression, okay, what do we want to show is that this expression here, okay, let me just put it, okay, there you go, that this expression here, this series is equal to that. I want you to look at this. If you're gonna notice, this portion is common to this sum. That portion there, the one that I'm trying to put a circle, right? And then you have there now, let me just continue that, okay? So this one now, I can factor this out. So I can have there the sigma of n equals 0 to the 3n of x to the n factorial times this one is 1 plus omega n plus omega 2n. Alright? Because that is omega 2n, that is omega n. Okay? But what do we know? What do we know from our first question? So we have said that 1 plus omega k plus omega 2k is equal to 3. Okay? Because these are all multiple. These are all multiple of 3. So therefore this is actually equal to 1. Alright? So that is actually equal to 1. And so we have here that 3, this is now 3 times the sigma of x to the n factorial from n equals 0 to 3n. Now let's try to check the question. Is it similar now? So if you're going to look at the question there, this, we got that. This one is not. Okay? But if you're going to look at it properly, these two are actually the same. Why? Because if you're going to look at that, so this is now, what are the elements of that? So there's 3 times, let's just look at this one here, of x to the 0 over 0 factorial plus this one if n equals 1, so x raised to 3 over 3 factorial plus x raised to 6 if n equals 2, that is 6 there, 3 times 2 is 6, so x to the 6 over 6 factorial plus and so forth and so on. But what is this one here? What is this? That's exactly similar to this, because if you're going to look at that, that is actually equal to x to the 3n over 3n factorial for the sigma of n is equal to 0 up to n. Alright? That is exactly similar to that, times 3. And there you go. So we have proven that this expression, that this sum of series is equal to this one. Again, it just looks complicated, but actually is not as complicated as it is. The only thing that you need to know is the definition of the s sub n of x, and just what do you call this one? Just apply that one carefully, okay, and visualize the problem. Okay, the problem itself is actually giving you a clue on how to solve it. So on the next video, I'm gonna cut this video here. In the next video, we're going to prove the last part of the question, which is deduce that the limit of n, the limit of this one, of this series as n approaches to infinity is 1/3 e to the x plus 2/3 e to the negative half x times cosine of x is square root of 3 divided by 2. Thank you.